Welcome to 6-9 Probability and Predictions. We have two objectives. First, find probability of a single event. And then we're going to use sample to predict the actions of a larger group. In order to do this, let's go over some of the key terms. Outcomes, the result of an event in probability. Like when a horse comes in a horse race, or that when you flip a coin and the answer is tails. That's the outcome. Simple event is one outcome, like the flipping of a coin or a horse coming in, or a collection of outcomes, where, like in horse racing, sometimes we bet on the horse coming in first, another coming in second, and another coming in third. Probability, it's the act of measuring the chances of an event happens. This is widely seen in Vegas, gambling. It's the chances of an event happening or even not happening. Sample space, the set of all possible outcomes. Like on a die, it has 6 sides, 6 numbers, so there's 6 possible outcomes. Of course, this changes when they introduce a second die, and now we have 36 possible outcomes when we introduce 2 die. Then there are 2 different types of probability. Theoretical is what should occur, and experimental, what actually occurs. So we can predict something based on the math, and after we do our experiment, something completely different happens. The key concept for probability is the probability of an event is a ratio, fraction, that compares the number of favorable outcomes to the number of possible outcomes. So we're not talking about what we don't like, we talk about what we do like, and we place that in the numerator. And the total of outcomes, possible outcomes, goes on the bottom, the denominator. As stated in the key concept, we put it in a ratio or a fraction. And the probability of an event is always between 0 and 1. Obviously, if we set it up as a fraction and our answer is 0, that event is not likely, or we expect it never to happen. If we were to set up our ratio, our fraction, and the answer is 1, we are certain that it will happen. So the closer probability is to 1, the more likely it is to occur. So if you look at this number line here, 0 to 1, 0 being 0%, and 1 being 100%. Everything else in between, depending on where it is on the number line, closer to 0, not going to happen. Closer to 100 or 1, it's probably going to happen. Suppose a number, cube is rolled. What is the probability of rolling a prime number? First off, let's talk about our sample space. Our sample space is what numbers are found on the cube. On a cube, our numbers are 1, 2, 3, 4, 5, and 6. That gives us a total of 6. So that is our sample space. Next, let's find out our favorable outcome. What do we want? We want prime numbers. And if you remember, that's any number that only has itself and 1 as a factor. Let's see here. I know that 2 fits that bill, 3 and 5. We can't consider 1 because 1's an anomaly. And we don't consider 4 because 2 times 2 is 4 and 1 times 4 is 4. So it's got 2 sets of factors, and the same thing for 6, 2 times 3 and 1 times 6. So our favorable outcome, that total is 3. If you remember the formula, favorable is on top, that was 3. Our sample space, or our total number of outcomes, is 6. With any fraction, ratio, we want to make sure it's in simplified form. It is now. So our fraction is 1 over 2. That's the probably 1 out of 2. Or, more than likely, it might be put into a percent or 50%. And if you remember, 1/2 or 1 divided by 2 is 0.5. And to change that into a percent, we move it 2 places to the right, filling this void there, and adding the percent sign. So that's how I got 50%. Those are the 2 possible ways to write the answer. Suppose 2 number cubes are rolled. Oh, this is different. We now have 2 die, both numbered 1 through 6. Find the probability of rolling an even sum. So we need to find out the total number of outcomes. Well, this chart here will help us out. It shows all the different combinations we can get rolling 2 die. And we can count all the rectangles, or we can do simply something like this, that we have 6 numbers and 6 numbers again. 6 times 6 is 36. Do what you want, count all the little boxes, or take the total number each die has, 6 times 6, and that gives us the answer. Then we need our favorable outcome. What is our favorable? It's even sums. That means when we have 2 die and we add the 2 numbers that come up and the total is even. Let's look at our first one, 1 and 1. Well, if I added 1 plus 1, I get 2, so that's an even number. And I would go through and I would do something like 1 and 2 on the die. 1 plus 2 is 3. That doesn't work. Let's try the next one. If I rolled a 1 and a 3, 1 plus 3 is 4. That's even, so I'm going to keep that. And I continue doing that all throughout this chart, and I find that I have, here we go, 18 even out of the total, which was 36. I want to make sure that my fraction is in simplified form, which it is. I have this as an answer, or I could change it into a decimal, then move it 2 places and make it a percent. So 50% or 1 over 2 are the acceptable forms of answers. The table shows the result of an experiment in which a coin was tossed. Find the experimental probability of tossing a coin and getting tails for this experiment. Experimental probability is what actually happened when we did the test. And this is our test right here. We have all the information that we wanted. We have a coin with heads and tails. We flipped it, and we got 14 for heads, and we got 11 for tails. So now let's build a ratio. So our sample was 14 plus 11, so that's our total. Our total is, of course, adding those two together, we get 25. Then our favorable, or our favorite, well, we don't have to do any counting. They told us we got 11 tails. Now let's build our ratio, which is 11 over 25. Is it in simplest form? Yes, it is. Or I can write it as a percent. How do I do that? 11 divided by 25 is 0.44. Then I just go ahead and move my decimal 2 places to the right and add a percent sign. And that's my other one. The experimental probability is 44% getting tails. Food. Well, food's important. The graph shows the result of a survey. Out of a group of 450 people, how many would you expect to say that they prefer Thin Mint cookies? All right, this is a great question. This has to do with cookies, but this is the type of question that all businesses ask, even Girl Scouts. What do we expect to sell, especially if we were given a group? Well, we already know the probability. We don't need to find probability. It says it all over the place here. It says that the Caramel Delights, we expect 19% people to eat those are in the shortbread 11%, our Do-si-dos 12%, are the peanut butter 13%. What we really want to know is, what do we expect for Thin Mints? And the answer is right here. We expect 26%. That's the probability. So what are we after here? Well, we have a group. We have a group of 450 people. And it says it right here, a group. So that's our total. We want to know what part of that 450 are going to choose Thin Mints. So what we're going to use is proportions. So we're going to go back to something we learned previously, which is proportions. So if you recall, we have a proportion where we're comparing two ratios, part over whole. We want to know what part of the group, or the whole, 450, is going to eat cookies. We know that we have a prediction that 26% of them will eat the cookies. But what is the actual number? Well, we're going to go back to proportions. We're going to cross multiply. So 100 times x, and then 450 times 26, 11700. All right, 11,700. Now we're still not done yet because we haven't isolated the x. We're going to divide both sides by 100. I'm left with x. And I'm just going to use something simple here. The zeros will cross out, and I get 117. I expect 117 people in the group of 400 to buy Thin Mints. And that, ladies and gentlemen, is something that we use probability for. We find probability with using our math, and then we take it out to the real world, and we make predictions so the Girl Scouts can make sure that they have enough Thin Mints to sell and they don't run out.